Hello, my name is Clarita Chua, and my final year project is about BERT, name entity recognition, on the emergency response system. The agenda of this presentation will cover a short background of the emergency response system and then going into the introduction of my research topic. Next, I'll go into my proposed approach and the experiments I have conducted. In emergency response centers such as police stations, call operators have to quickly respond to the caller and disseminate the information to the relevant department. 3,999 calls are received daily in the Police Operations Command Center in 2020, and 80% of emergency calls to Singapore Civil Defense Force are medical related. With call operators usually working around the clock in 12-hour shift, there's a need to relieve their workload and improve the process of disseminating information, because every second matters in any critical moment. There's an existing emergency response system that uses natural language processing to help emergency responders in their task. Natural language processing is a subfield of AI where we train computers to understand human language. With these keywords extracted and filled in automatically into the system, the emergency responder can focus on interacting with the caller. This will relieve their workload significantly and reduce any human error. From the example, the caller would say, "I'm currently at Chinese Garden being chased by a person with a black hoodie and holding a gun." The relevant information detected is the location, characteristic of the perpetrator, and the weapon. However, this ER system has limited functionality and is only capable of detecting location characteristics of the person and the weapon keywords. It is very important to accommodate to the changing climate of coronavirus, and with 80% of these emergency calls mostly medical related, the ER system should be more adapted to extract medical and COVID-19 related information. And thus, we need a system to develop and scale NER models easily to accommodate to different scenarios. This leads to my project, where the purpose is to improve the deployment and scalability of NER models on the existing emergency response system by developing a robust and automated pipeline which can train different NER models in the COVID-19 context. The project objectives are essentially to identify the best BERT variant NER model on the datasets related to the emergency response system. The second objective is for the ER system to capture essential COVID-related information. And lastly, explore the impacts of data augmentation within the curated datasets. I will now introduce the curated datasets that I'll be working on for my experiments. The first is the general emergency response dataset used in the previous ER system. It can detect all the general information for emergency response, such as emergency type and the specific location of the caller, such as building number, street number, and postal code. The original dataset has 21,000 sentences, and after augmentation from the Pegasus, it will become 26,000 sentences. As one of the objectives is to make the ER system more adaptable to the COVID climate and capture COVID-related information, there's another dataset created called the COVID dataset that's useful for contact tracing. It can help detect the name of the person, location, and symptoms such as headache or coughing. The size of the original dataset is 33,000 sentences, and after augmentation, it became 42,000 sentences. There are many different pre-trained language models to use for NER, and the one language model I wanted to focus on is called BERT. BERT is a language model published in 2018 that achieves state-of-the-art performance on multiple NLP tasks. It's a novel approach to transformers by applying bidirectionality learning and using a mass language modeling technique to increase its context awareness. It also uses the concept of transfer learning, where it is pre-trained on a large corpus and can be fine-tuned to a smaller target dataset, which I will be doing for the two curated datasets I've mentioned in the previous slide. I'll be utilizing the state-of-the-art BERT as a part of the NER model. You can see on the right diagram that a sentence is fed into the BERT model, and then it goes through a linear layer to give the entities of the sentence. Another reason I chose to use BERT is the different versions of BERT I can experiment with. BERT is originally pre-trained on a book corpus and Wikipedia. Distilled BERT is the lighter and distilled version of the BERT model with 6 layers compared to 12 layers. Roberta is known as a robustly optimized version of BERT, and it's pre-trained on a larger corpus. With one of the objectives to identify the best BERT variant model for each curated dataset, I've created an automated and robust pipeline to train NER models in bulk. It can help developers easily develop, scale, and deploy different NER models for the ER system. This automated pipeline is called the Automated NER System, and it consists of 3 modules: the Data Preparation module, the NER module, and the Model Inference module. The first module is data preparation. It receives a configuration file from the user, which indicates what BERT model they want to train the curated dataset, and of course to give the location of the data files. It will then tokenize the sentences and encode the tokens. This will prepare the train and validation datasets that will go into module 2, where the BERT model is compiled and trained on the prepared datasets for 3 epochs. The last module is model inference, which allows the model to be deployed and put into production easily. With the tokenizer and NER model trained on the target dataset, a sentence can be fed into the module, and it outputs the sentence and the detected entities. This automated NER system was used to train the 3 different BERT models onto the general emergency response and COVID dataset. I wanted to identify the best NER model for each dataset in considering both accuracy and F1. Roberta NER model performed the best in both curated datasets. Another experiment was conducted on augmented datasets of the general ER dataset and the COVID. I wanted to see the impacts of data augmentation if it improves or worsens the performance of the BERT variants. The findings were quite interesting. Even though Roberta performed better in the original datasets, distal BERT and BERT performed significantly better on the augmented datasets. On the other hand, Roberta had a low performance within a range of 1 to 13%. According to a paper written by Longpre, a model can only benefit if augmentation provides linguistic patterns that have not been seen during pre-training. This explains how BERT and distal BERT showed the highest improvement with augmentation, as the dataset they have been pre-trained on is significantly smaller than the Roberta's dataset. In conclusion, an automated NER system was built to provide developers a way to easily develop and deploy NER models on the ER system. With the automated NER system, the best BERT variant NER model for both dataset is Roberta. But when it comes to data augmentation, distal BERT had a significant improvement in performance. By fine-tuning BERT onto the COVID dataset, the emergency response system also can handle contact tracing, where it can capture essential COVID-related information. And thank you for listening to my presentation.